Good afternoon. I'm Hugh Dyer, Associate Director in RSK's Geoscience business. Welcome to the May edition of our 2024 series of Down to Earth webinars. These sessions cover a broad range of subjects through the year, and we are available afterwards on our YouTube channel alongside previous talks. Our talk today will focus on redefining waste management and resources, and is presented by Rachel Hill from our Waste and Resources team. Firstly, a brief note on housekeeping during the talk. All attendees' microphones are automatically muted through the webinar. During the presentation, you can post questions online, and there'll be a Q&A session at the end of the presentation. So please submit your questions as we go through the talk, and we'll answer these at the end. As many questions as possible will be answered. Those that can't be answered due to time constraints will be answered after the webinar. Shortly after the webinar, you'll receive a link to a short survey. If you could take a few minutes to provide feedback, please, so we can improve on our future webinars. Now, let me welcome our speaker today. Rachel is a Senior Waste and Resources Consultant within the RSK Geosciences Waste and Resources team. She has an extensive portfolio of projects with over 8 years of experience within the construction and civil sectors, specialising in environmental and waste management. Rachel's hands-on expertise involves implementing circular economy principles and waste management practices, as well as assisting businesses and organisations in achieving their waste reduction and sustainability goals. She has worked on high-profile projects, including HS2's Old Oak Common site, the set-up and operation of a hazardous asphalt recycling facility, and on River Thames scheme material reuse assessments. Rachel also holds a WAMITAB Level 4 qualification, is a Chartered Resources and Waste Manager, and member of the Chartered Institute of Waste Management and Southwest Centre Council. So I'll hand over to Rachel now to give us an insight into the drive towards circularity in waste and resources.
Excellent, thanks Hugh. So as explained, today I will be looking at circularity in construction and providing an overview of some of the mechanisms that can be utilised to instill circularity in construction projects when thinking about waste and resources. I'll be having a look at how the waste hierarchy and the circular economy principles tie in together, and then take a look at the construction journey, looking at design and pre-planning, on-site management and data collation and post-construction. So before I get into this, I want to explain why we need to cover this topic and why it is such an important topic in the world we currently live in. Moving to a circular economy in the built environment is really important. It will help to reduce the use of natural resources and also the production of greenhouse gas emissions, which contribute to climate change, which is currently an issue that we all face. And not only this, for the waste and resource industry, it is the next step in the waste and materials journey. For wastes to no longer be seen as a burden and that thing you need to find a disposal route for, but to be seen as a resource and identify how they can be reused and repurposed throughout a construction project. In 2018, the latest figures available, 62% of the UK's waste originated from construction, demolition and excavation operations, and it is a highly resource intensive sector with 100 billion tonnes of raw materials being extracted for use worldwide across the buildings and construction sector. Moving towards circularity also aligns with the UK government's commitment to circular economy as part of their circular economy package of policy and legislation. So there is a real need to focus on turning waste into a resource and redefining that waste and resource management within construction. So onto the waste hierarchy and circular economy. Both the waste hierarchy and circular economy have evolved over time to emphasise the design and use of a product or material before it turns into a waste. The waste hierarchy is a tiered approach which aims to maximise prevention and minimise, or ideally eliminate, waste disposal, And the circular economy aims to eliminate disposal and take it that one step further in preventing the generation of waste altogether, and then maximise the use of the resource from those materials. Therefore, we can see that circular economy principles and the waste hierarchy share a joint philosophy, aiming to manage resources by rethinking, redesigning and repurposing in order to improve the resource effectiveness of a product or material and to reduce the generation and adverse impact of waste. The minor difference is that the waste hierarchy still allows disposal, while the framework of a circular economy doesn't, looking for materials to be reused and waste to be designed out to begin with. The circularity principles can cover all materials. It doesn't just need to apply to items, it can apply to excavated materials and materials produced during demolition. Considering both these concepts to create a sustainable future, a regenerative circular economy that rewards the reuse of finite materials and resources must take priority and be the first consideration in the construction process. Firstly, I'm going to have a look at the design and pre-planning. So applying circular economy principles and increasing sustainability in a construction project is something that needs to be implemented as early as possible. Design and pre-planning is a crucial step to ensuring that circularity and sustainability is weaved through as many aspects as possible in a project. And it is a time to understand goals, policies and requirements, and time to start the ball rolling with some of the mechanisms and actions that may be required to implement that circularity in the project. So firstly, the design review. So designing the project for optimization is a key first step. It is important to give consideration to various aspects of the design of the project to help implement circular economy principles. Consideration to the longevity of the design, for example, how long will the materials and design itself last for to ensure the maximum use of products in their current use and state. Design flexibility so that improvements and changes can be made. Consideration to the adaptability to changes in the environment as the climate changes around us, and also thinking about assembly, disassembly and recoverability considerations to ensure materials can be disassembled in a state that can be reused for the same purpose again, or can be easily recovered as a resource for reuse elsewhere. Circularity doesn't just need to apply to the building and structures being created, but also the materials which are generated through the process. So materials created when demolition occurs and the materials generated through the site preparation and excavation can all be considered using the same design aspects. Collaboration and knowledge sharing, along with utilising previous lessons learned, is also an important step at this stage. Different members of the project, consultants, subcontractors, all have experiences and knowledge that can be brought together into the project, with consideration given to innovation, new products and new techniques which might not have been tried before. It may also be a good time to start thinking about the metrics, benchmarks and indicators within the project, whether there are any certifications being aimed for example, BREEAM or PAS 2080, and how can the design and construction methods work together to achieve these. So next is the pre-planning and early engagement. This is a concurrent important step alongside and following the design review, and it's where the team can start identifying what mechanisms may be required to implement circularity, especially with consideration given to those which may require permits or regulator liaison, and also to allow enough time for these to be undertaken. Early engagement with subcontractors, consultants and regulators about the potential practical steps required is also useful at this stage. Subcontractors will have a wealth of experience and knowledge that could enhance the circularity within the project. Consultants can start to action the mechanisms where there might be permits or supporting documents and reports required, and regulators can provide early advice and guidance around what potentially can and cannot be done. Supply chain engagement is another one at this stage, so understanding what they can do to reduce waste being produced through streamlining, off-site construction and even packaging reduction, but also what circularity mechanisms they can provide, such as take-back schemes and repatriation schemes. This stage is really crucial, as ideally everything should be identified and in place prior to the project starting on the ground to make the most of those circularity mechanisms available. So starting to think about the mechanisms that can be used to support circularity decisions at this stage. Firstly, site waste management plans. So these are often used, see them on lots of different projects, but they come in many different forms. Some can just be a bit of a tick box exercise to say that there is one in place, but if done correctly and early in the project, they can be a really useful tool to identify where improvements can be made. Even if the waste volume and information are still estimates at this stage, the tools can identify your hotspots of material and waste generation from the works, the types of material generated, and from which phase of works these will arise from. This can then act as a bit of a guide and be further refined, so thinking about where are there large amounts of materials or wastes being produced, what can be done to prevent these from being created, so could the design be changed, or could other mechanisms be used, or can this material be reused elsewhere in the project? Where there are difficult to manage wastes, what could be done with these to increase circularity, and consideration given to the chosen routes where waste is needed to go off-site. Is it going to a reprocessing facility, or is it just going to landfill? If it is going to a reprocessing facility, what are their recycling rates, and are there any better options available? Alongside this, it is a useful time to start considering carbon assessments and putting some high-level figures to the activities being undertaken. This can help with sustainability considerations and then also ends up providing a different view on the materials and wastes being produced. So your site waste management plan looks at quantities and volumes, but your carbon assessment might actually look at how much carbon is being associated with those activities and the materials being produced, and show some different kinds of hotspots that you might want to have a look at during the project. So optioneering and material reuse feasibility assessments are another useful pre-planning tool. To help assess what mechanisms can be utilised, optioneering and material reuse feasibility assessments can be undertaken. These can be completed on the one site or project or on a larger scale. And if there are several projects and sites, this may actually open up more options and have more scope for implementing circularity on those individual sites and between sites. These assessments utilise the site waste management plan and the design information to understand what materials and potential wastes will be produced from the works, whether it is demolition or excavation or both, and it looks at where these materials can be reused in the design, whether this is for temporary or permanent works, or even turning these products with end of waste mechanisms, turning these into products, for end of waste mechanisms for reuse or resale. The assessment can assess each of the available mechanisms and understand the applicability based on the project aims around material reuse and circularity, the materials and waste being produced, and timeframes and feasibility. The outcome is a series of suggestions and mechanisms which may be used alone or in conjunction with others to manage the materials and wastes and turn them into a resource for the project or projects. So some of the mechanisms which might come out of these assessments. These are kind of ordered in circularity favourability. Some mechanisms allows for materials not to become a waste. Therefore, this offers more flexibility longer term so that waste regulations won't apply. Others utilise a material once it is defined as a waste, and others allow for a material defined as a waste to reach that end of waste status and criteria. So firstly is preventing the material from becoming a waste in the first place. The Environment Agency puts this burden on the producer or holder of the material, and that as the producer or holder, you should work out if your material is a waste, whether it has been discarded or whether it has never become a waste and meets those reuse requirements, or whether in some circumstances it has stopped being a waste and meets that end of waste test. So everyone should be familiar with the definition of waste and that discarding element, but what about the reuse element? So according to the EA, a material will not be a waste if the following apply. It is used for the same purpose for which it was designed, so the use must not be subordinate or incidental to the original use. The previous holder intended it for it to be reused. No repair or no more than minor repair is required to it when it is transferred from the previous holder to the new holder. Any necessary repair is going to be done. Its use is lawful and is not managed in a way that indicates that it is a waste. So for example, if you are demolishing a building and doing it in such a way where the brick or blocks are saved and are in good condition and can be reused in another project, this then may apply. However, if a material becomes a waste before it is reused, you will have to apply the end of waste test to then use it. The end of waste test is a bit more complicated and is where a waste material has been through a recycling or other recovery operation and meets all the conditions of the end of waste test to be classed as a non-waste. Article 6 of the Waste Framework Directive sets out the end of waste test, which contains 4 conditions that all recycled or recovered material must meet to achieve end of waste status. These surround a specific use, market demand, technical requirements, and no overall adverse impact to the environment or human health. A submission needs to be made to the Environment Agency, and this may be a bit of a lengthy and costly process if you are just one singular construction project. However, if there is multiple projects and some form of permit may be required or to allow for the reprocessing, it may be something to look into and may help with that flexibility of material and product reuse. So for excavated soils, the CLARE definition of waste code of practice is there, and this can support with circularity being implemented and the excavated material not becoming a waste. So if the CLARE DAOCOP can be complied with and the 4 principles within it demonstrated and evidenced, the excavated material can be reused on the site of origin or reused off-site without becoming a waste. Hub and cluster projects can be utilised if there is soils which require treatment prior to reuse, and therefore improving the resource reusability and longer-term circularity. Obviously, this does all need to be done using a pre-approved materials management plan and tightly controlled throughout, but it is a really useful mechanism, and it allows the reuse of large volumes of excavated material either on your one site or between sites, and should definitely be utilised more often. And this is especially with the upcoming exemption reforms next year. Another mechanism to have a think about is the RAP quality protocol, aggregates from inert waste. This is another end of waste option. In the project, if the project is producing inert waste, then you may be able to reprocess this under a controlled factory production control module and potentially other permit requirements to produce an aggregate product that can be reused freely on site or elsewhere, or even put to the market. Again, this helps to increase the longevity of the material and repurposing it, but there is specific criteria within that quality protocol that must be met and followed, but it can be quite a useful one. One along the same lines is the quality protocol relating to composting. So some mechanisms are where you can send material away for treatment and then have it come back to you in a usable form or no longer as a waste. These may be another option to keep the circularity in the project for those more difficult to manage or process wastes that are produced. So biodegradable materials are often created during the clearance and preparation of the site. The quality protocol for compost, which can be used in England, Wales and Northern Ireland to create compost, meets the end of waste criteria using that PAS 100 standard. This is the standard for the specification of composted materials, and that enables operators to meet the quality protocol. Once end of waste criteria has been reached, the compost can be freely reused in landscaping works or sold elsewhere because it has met that end of waste criteria and that waste legislation no longer applies. So as with the RAP quality protocol with aggregates, the protocol for compost acts the same. As long as the compost is produced has been created in line with the quality protocol, no longer be considered a waste, and ensures and this also helps to ensure that the specific standard is there that it's been made to, and that means that it protects the environment and human health. Obviously, if you do send some biodegradable waste to a composting facility and you receive some compost back, it won't be your exact same waste, but you can see how this off-site use of other mechanisms can help with that circularity and that pre-processing of that material and receiving a product back. Another mechanism to have a think about is regulatory position statements. So there is some out there that can aid in circularity. RPS 157 and 75 relates to asphalt management. So 157 allows for the reuse of hazardous or non-hazardous asphalt within the same site where it was lifted from, even if it is treated elsewhere, but noting there may be some other requirements, other permit requirements within this process. So for example, a Part B from your local authority. RPS 75 helps further, so this allows for the reuse of asphalt waste containing coal tar on other sites as hard paving subbase and binding layers, but not within surface layers. However, in this case, it is still considered a waste, so duty of care does still apply. But the really good thing about this is if you use this on a site and that asphalt then needs excavating in 10, 20 years time, the process can carry on. So next time it's excavated, the same mechanisms can be applied and that circularity is continued. One additional consideration in this stage of the process is embracing the software and programs which are available to support with applying circular economy. There are tools which can support with modular construction and dismantling. This provides a 4D experience with each piece of the model, knowing the resources and time required to complete it. This can support with scrutinising the materials being utilised to increase sustainability, understand the best dismantling sequence to maximise resource value, and also support with that CO2 estimation. Building circularity tools can aid with selecting circular materials, choose design that support disassembly, and aid in designing out waste by assessing end-of-life processes based on the material types used. And there's also material management softwares which can help with tracking materials and waste on and off site, even between sites on larger projects, and can also support with those upcoming mandatory digital waste tracking changes. So on to the next phase, and that on-site management and operational wastes. So site setup plays a really important role to ensure that circularity mechanisms implementation can be achieved. It sets the tone for the start of the construction stage of the project, and it also ensures that everyone involved is on board with the circularity aims as more subcontractors and workers join the project at different phases. Everything must be in place on site, so thinking about documentation being readily available, waste segregation areas and containers being well set up with good signage and clear signage, ensuring those who are involved in the circularity mechanisms are fully aware of the requirements and their responsibilities within those processes. And this helps me make things easier for everyone. And the easier that things are, the more likely the aims will be achieved. So clear project phasing, clear direction, and things being clearly marked out. Informing and disseminating information at the start and throughout the project helps to ensure everyone is aware of requirements, but also aids in increasing engagement. So explaining the whys, providing the reuse or recycling percentages, and also that carbon data, so people can help see the process and see the process that they're supporting and making a difference in. Another aspect to have a think about with on-site management is closed loop take-back schemes. I mentioned these earlier in that pre-planning, so having these implemented on site can really help with materials being sent back to those suppliers for reuse or recycling into new products or into the same product again. And these schemes have grown massively over the last few years and can be utilised for some difficult to manage waste streams as well. It is beneficial to liaise with suppliers and manufacturers and understand what schemes are offered and how these can be best implemented on your projects. Some examples here, we've got British Gypsum, plasterboard take-back schemes, Rico Floors vinyl take-back, and also Crown's can-back scheme as well for paint cans. So through the construction phase of the project, there may be waste streams generated which are more difficult to manage or may not have readily available circularity mechanisms. These may be smaller waste streams such as PPE or food waste generated through the kind of operation of the site, but they should all be considered to achieve circularity. This is when a further bit of research and the application of maybe some innovative or new ideas and also some past learning from other projects can be implemented. For items such as PPE, there are more and more recycling schemes popping up now, However, some may be more efficient than others due to the use of energy from waste compared to shredding and reusing those fibres for new materials. So it's good to have a bit of a question and interrogate to understand where those materials are going once you send them off site. For food wastes, there might be consideration given to on-site digesters. These can break down food waste using enzymes and agitation, and then only produce an effluent from all the broken down food waste. Liaising with waste contractors and understanding for cost wastes is a good one. Understanding where the end destination is and where there may be a more circular end destination. So, for example, reprocessing instead of energy from waste, or at least energy from waste instead of landfill. It's also things like aerosol degassers, which have been around for quite a while, but may be a useful one for enabling that metal component of those wastes to go for recycling and reprocessing and removing that hazardous component. Also using systems such as cardboard balers or styrofoam densifiers to make the waste streams easier to manage on site, and also ensure they're in the best condition possible to be recycled once they are sent off site. And even things such as septic tank digesters for sewage effluent are about now, and these can be used to manage that effluent produced from cabins and welfare units. These all tie into that circularity aspects and help improve waste management on site. And there is constant advancements and innovations in waste management which can be applied to reduce the loss of resource and keep things in use for longer in some form or another. So once your construction project has finished, there is the post-construction phase to have a think about. So the process for circularity doesn't stop once your construction project is finished. Data collation and review is a really important step following this. So project team want to ensure that the final figures of materials reused and those waste streams that needed to be disposed of are captured. Carbon assessments and site waste management plans can be returned to and reviewed. The original estimates of the materials and waste generated can be compared to the actual figures from the project, understanding what worked well, understanding what may not have worked as well. And then information can also be gained and shared with supply chain and subcontractors to aid in that future learning, and the data can be looked at, scrutinised and questioned to further inform the review and refinement process. So that review and refinement process is another important step post-construction. Implementing circularity should be a consistent process. It won't be implemented straight away on your very first project, but it can be something that grows and expands over time with every iteration, and this can improve your projects and reach those circularity goals. It can look at what can be done better and what can be done differently each time. These reviews and refinements should involve everyone in the chain as well, so from designers through to the building contractors and also your supply chain. This helps bring together knowledge, learning and collaboration and further implement those circularity principles in the next project and create those action plans that can be utilised. So in summary, there are a lot of options and mechanisms to implement circularity in the construction process when thinking about waste and resources. The view on circular economy should be applied to all materials produced during the demolition, excavation and construction phases. Circular economy principles can be applied and achieved through the whole project, through allowing time to undertake the design process with reviews and circularity considerations such as that longevity, flexibility and disassembly, by giving pre-planning and early engagement the importance it deserves, utilising the previous lessons learned, sharing knowledge and collaborating together. By applying circularity mechanisms to manage materials such as soils, inert wastes, biodegradable wastes and those difficult to manage waste streams, and by taking the time post-project to review data, understand what worked, understand what may need some refinement, and take those lessons onto the next project. This can all enable circularity to be applied within our industry, turning that waste into a resource and also protecting our environment for future generations to come. Lovely, so thank you for listening, and I'll hand over to Hugh now to see whether we've got any questions.
Thank you, Rachel, for a very, very interesting talk. We have a few questions that have come in. Please submit your questions now if you want Rachel to answer those burning questions you have. So firstly, I think you partly answered this, but what are the options for waste materials which cannot be used as a resource elsewhere?
Cannot be reused as a resource elsewhere. So yeah, I think within construction projects, there is a lot of different materials and wastes that are produced. I think it's having a look at what different options there might be. Things are changing all the time. Companies are looking at lots of different avenues and options, whether it's through those take-back schemes or whether it's through kind of an innovative recycling and reprocessing scheme. So I think it's good to keep an eye on what's happening. And if you do need to remove that waste off-site, have a look at where it's going to. Look at what your best contractor option is, whether you can apply that waste hierarchy, whether you can apply some aspects of circularity at least within there, and see what you can do with that waste really. But things are changing all the time, so hopefully in the future, if you can't apply those circularity principles now, there will be an option to.
Brilliant, thank you. What is the most useful mechanism to support implementing circular economy principles into a project?
Yeah, so I think there's probably a couple of different ones that need to be thought of together. So I think time is a really crucial one. So giving the project the time at that design and pre-planning stage to make sure that all those different aspects are looked at, scrutinising that design, where can circularity be applied, and then I think probably the other one within those mechanisms is actually preventing that material from becoming a waste. So looking at that reuse test from the EA, or applying that Clare-Dowcop and materials management plans. You're allowing more flexibility then. If that material isn't deemed a waste, you can use it in a lot more different places. And you don't have all those kind of testing and waste transfer notes and things like that. I think also the end of waste is probably another good mechanism. So if you can't prevent it from becoming a waste, can you apply that end of waste? Can you reprocess it and recycle it so that it becomes a product at the end? I think that probably the caveat with the end of waste is that normally it is reprocessed and recycled, so you may be losing some of that resource value, but you can still reuse it in hopefully a product elsewhere within a project or sale.
Okay, excellent. Got a question here. Can you clarify what is the role of local authorities under the Dowcop?
Oh, that is a good question. It's probably something I don't know off the top of my head, but I'm happy to go away and have a little look at that one and yeah, get more of a refined answer.
Okay, fantastic. What legislation is available to approve circularity on road projects?
Road projects. Yeah, so provide.
Approve.
Approve. Okay, so I think within road projects, it's probably one of the more easier ones because you've got some of those kind of waste streams like asphalt, maybe some hardcore, maybe soil coming out of them that you can apply those different mechanisms to. There's the different RPSs that can be used with that asphalt, which is a really good one. And there is a lot more schemes popping up now where companies can recycle that hazardous element and also do it either in situ or ex situ. Hardcore, obviously, you've got your different mechanisms with the RAC quality protocol. And then soils, you can look at things like Clare-Dowcop, maybe moving it between sites, utilising those material management plans, especially as things like those exemptions are changing, the reforms are coming. It's looking at what other materials are there now. And also you can, yes, having a look at the approvals, it's having a look at whether there is any kind of benchmarking or metrics indicators out there that can be used to assess that circularity. Had a bit of a mention about the different software out there. There might be something there for highways. I think for the built environment and kind of more structures and construction, there's a lot of that there at the moment. Maybe for highways, it needs to catch up a little bit, but I expect it will do.
Right, brilliant. what are some of the barriers that can be faced when implementing circular economy into a project?
Yeah, so I think not making the most of that design and pre-planning element is one that can happen. So not giving yourself that time to assess. It's not always really feasible to implement a lot of these mechanisms once you're in that construction phase. So that pre-planning and design is really important. And then for some of the mechanisms as well, you do need permits for some of them. And specific documents. So it's making sure that those are in place, making sure that they're approved where they need to be. It's kind of giving that time and mechanisms to apply that circular economy. Yeah, and kind of remove some of those barriers if you can give yourself that time to assess.
Right, I think a couple more questions, if that's okay. There's a couple around carbon. So can there be a conflict between reuse of material and carbon reduction where long distances between sites or significant processing is required? And then the follow on from that is, what tools are available to assess the carbon reduction or the carbon impact through the reuse of materials?
Yeah, so I think for the first point, there definitely can be a conflict, and it's finding that balance within the project. Yeah, there's not always those easily accessible recycling and reprocessing sites. I hope as the industry kind of embraces circularity, then there'll be more demand, so more people will be setting up these different reprocessing sites, and kind of that demand will feed that. I think it is doing your different carbon assessments, understanding what your ultimate priority is on that project. So kind of which one may kind of win, I suppose, in that regard. But you do want to try and apply both at the same time, maybe doing different carbon assessments for different scenarios and seeing which one may have more circularity, which one may save more carbon, and kind of making that decision based on there. I think the hope is in the industry that as I was saying, as it kind of demand grows, there will be more options. It won't have to travel that distance. It maybe won't need to be reprocessed as much. More things can be done on site, and that can then help that carbon and then also help circularity at the same time. And what was the second point? Sorry.
What tools are available in the industry to assess carbon reduction in material reuse?
Okay, so there is quite a lot of different softwares out there at the moment. Can't think of any directly off the top of my head, but there is those kind of different softwares that can help. I think I mentioned a couple on the screens. There's like the BIM can help look at different structures and where those materials have come from, the different carbon embodied within them. There's also, I think it was the Building Council also have different systems. There's lots of different carbon tools out there. It's probably about finding the one that best suits what your activity is. Some are more tailored towards different construction, demolition, excavation activities. So it's finding the one that's best for you. I think there's, for example, like highway specific ones. And then also DEFRA have their published generic carbon factors as well. So if you do struggle to find a tool that can be readily used for what your project involves, you can also use those DEFRA figures as well. Carbon assessments don't have to be super in-depth if you don't want them to be. They can be a little bit more high level. You can do them yourself, but it just gives that an idea. And obviously it will still show where those hotspots are within your project and what materials you might want to focus on.
Yeah, I was going to say, I know that our LEAP team have got their credits calculator. I know that's quite advanced now for foundations, and as I understand, they've got one that can calculate carbon in the MMP assessment as well now. So yes, definitely talk to our LEAP guys about that if that's of interest to you. I think one final question. What is the incentive for smaller developers to push this where there's not the economy of scale?
Yeah, that's true. So I think there is a potential risk that sometimes these mechanisms can mean that projects take a little bit longer and cost a little bit more. but it is where the industry needs to go. I think I kind of set out that picture to begin with of where we all have that responsibility within the world at the moment, with the different impacts that are happening in construction, excavation and demolition is a very resource intensive sector. So I think it needs to be seen as the priority. So implementing that circularity, reducing impacts on environment should be something that everyone strives for in their projects as much as practically possible. You know, maybe some kind of big mechanisms aren't as feasible, but maybe as many smaller mechanisms as possible are being implemented, can help reach those circular economy goals and see that waste then as a resource.
Brilliant. Okay, so we'll end the questions there. Any further questions will be answered once Rachel's had time to process what's gone on here and review these. Our next Down to Earth talk will be on Tuesday, the 11th of June, provided by our surface water management team, looking at silt pollution on development sites. This will be the first of a two-part session looking at the issues with silt on development sites. So please remember to complete the feedback following the presentation. Thank you very much for attending today, and we'll see you again in June.